So what we have here, guys, is a loaded test tube of total mass m. Okay, so we're just looking for key parts here. Okay, so total mass being m, floats in water and is in equilibrium when its length d is submerged. As shown, the upward force exerted by the water in the test tube is F. Probably just need to draw in F there. F. Okay. Given that F is directly proportional to the submerged length, find the constant of proportionality in terms of d, m, and g. Okay. So what goes up equals what goes down. So the force up refers to the buoyancy force. The weight going down's got to be mg. Now, it says that the buoyancy is proportional to d. Yeah. So therefore, the buoyancy is equal to kd, where k is a constant of proportionality I just made up a second ago. Okay. You could use any letter you want, provided it's not already used. Now, buoyancy is a force. We're going to replace that with F. F equals ma. Okay, so at equilibrium, the force going up equals the weight going down. So basically, the force mg equals kd. Okay, and then k, which is a constant in proportionality, must be k is mg over d, and that got me 10 marks out of 25. Alright. Now, the test tube is now pushed down a small amount and is then released. Show that it will oscillate with a simple harmonic motion and find the period of the motion. So, what I have to do is I'll leave my k equals mg over d up here. Now, what happens next is, guys, I drag this down a bit further. So in a way, it's no longer d, it's going to be d plus x. We're going to imagine that we drag it down an extra distance x underneath its equilibrium, okay? So it's deeper than it should be. So the forces up do no longer equal the forces down. There's an imbalance, okay? So net force. Now remember that x went down in this direction. You pulled it down by a distant x going downwards, okay? We want to prove that a equals minus omega squared x. Okay? The force is only going to be negative. Force will only be negative if I do force down minus force up. So force going down minus force going up. That will make it negative, because when you displaced it downwards, the buoyancy force overtook the weight, because the buoyancy force is now going to be stronger. Okay. So what is the weight going down is mg. What is the force going upwards? Well, we learned earlier that buoyancy force was equal to k times distance. Okay, the distance it's dragged under the water. Now that distance is now changed to d plus x because you dragged it down an extra bit of distance longer. So our new buoyancy force for this part of the question is going to be k times d plus x. Okay, so that's going to be minus k times d plus x. And then what we're going to get is mg minus kd minus kx. Okay, now we're going to have to use the we're going to have to get rid of k somehow. Yeah, we're going to substitute in k. So it's going to be mg minus mg over d times d minus mg over d times x. And what we can see is that mg, those d's will cancel each other out, and this is still net force. And then we're going to get the two of them. That will be mg minus mg, which is going to cancel each other out. So you're going to get force equals minus mg d times x. Now, you got to remember, we're trying to prove acceleration equals minus omega squared x. So acceleration is mass times force equals mass times acceleration. Now the mass masses will now cancel. And what we're going to get is A equals, I suppose I changed it to minus G over D. That'll work as well. I have a slightly different answer to the book, but should be okay. Yeah, it's the same thing. So minus G over D times X. Okay, so I can say this is simple harmonic motion. You can see the marking scheme. Once you get the acceleration equals minus something times displacement, you can see, just write down SHM. You don't even have to go on a big long spiel about it. Just say simple harmonic motion. I myself will always say where omega squared equals G over D, hence omega equals the square root of G over D. Everybody understand where I got that from? Remember, acceleration equals minus omega squared W. So if this is our acceleration, therefore this part here has to be omega squared because it's the same formula as omega squared x. So omega equals G over D, so hence G over 2. As for the periodic time, find the period of the motion. Period t equals 2 pi over omega. T therefore is going to be 2 pi divided by root G over D. Root G over root D is the same thing as 2 pi over root G by root D, because you can break up the surd. Then bring up the fraction and turn it upside down. So we're going to get T equals 2 pi root D over root G. And that's what you have there. So that's your 25 marks for part A. It's actually quite an easy question. Any questions about it? What happens here, guys, is this. A skier of mass m is skiing on a hillside when he reaches a small hump in the form of the arc AB of a circle of centre 0 and radius r as shown in the diagram. OAB lie in vertical plane, and OA and OB makes angles of 22 degrees and alpha with the vertical respectively. The skier's speed at A is 8 meters per second. The skier loses contact with the ground at point B. Find the value of A. Okay, so here's what we're going to do. We're going to mark these 2 points out here, and in effect we're going to treat it like a vertical circle question. Okay, we can take terra firma, or where your potential energy equals 0, as this as this part here. So I'm going to draw that line, and that's where my potential energy will equal 0. It doesn't have to be that point. You could actually draw that. You could say potential energy equals 0 down here if you wanted, and you'd still get the same answer once you have a consistent system. Now, what we're going to do here, guys, is we're going to do the remember, when you have motion in a vertical circle, you have 2 formulas. You have conservation of energy, and what's the other one? Conservation of energy is one equation. What's the second equation? Anybody? Centripetal acceleration, or force / force, whichever one comes to mind. Now, let's start off with if we start off with centripetal acceleration, what are your 2 choices? You can have A equals mv squared over r, or you can have A equal, no m because it's acceleration, not force. V squared over r, or you can have r omega squared. Which one would you like to choose, and why? Any keywords lead us to a choice? That's what's leading me to my choice. Speed, not angular velocity. Speed is what they're talking about. That's the currency we're using today. So that means that this v squared over r is not a good idea. Now that that's decided with, what we're going to do next is we're going to turn them into forces. So force equals ma. Ma equals m r omega squared. Okay, so mr omega squared. Now, let's see what's going on with our weight. Okay, so we're gonna do it. We can find the central pedal as it leaves. We're gonna find the acceleration as it leaves it. Okay, so what I can say here is that that's mg going directly down. Everybody agreed with that? What direction does r go in? R is always perpendicular to your surface you're standing on. So R is always in line with the radius. Okay? And your velocity is a tangent to that circle at that point. Now, what's going to happen next is we need to break up the weight into its two components. So anybody remember what way to break up the weight? We're going to bring it up, down. Oh wait, straight down. And then we're going to break it up parallel and perpendicular to the radius. So, by use of that's alpha by alternate angles, isn't it? And by another alternate angles, that's also alpha. Do you have a question? Sorry guys, just realised I'm using phi squared over r, then I just randomly decided to take the other equation for no reason. mv squared over r. My bad. Okay. Now, what happens here, guys? mg going straight down. That makes that mg cos alpha, and makes the other one mg sine alpha. Down and across. Now, can anybody tell me what two directions are going for the force? Remember, centripetal force is the force towards the center of the circle. So what is the force towards the center of the circle? So remember, you're at this point here, and you're looking for motion that's going in this direction here, back in towards the center of the circle. So is there any force going back in towards the center of the circle? What is it? mg cos alpha, perfect. That's going diagonal left down. Anything going diagonal right up? R. It's getting supported by the force R. Okay, and that will equal my mv squared over r. Do we know what r is? What's the radius of its motion? 7. It's always 7 meters. So we're going to go for 7 there, okay? Now, cross multiply up. Now the trick is, do you know when you're leaving, the point of leaving the point of lifting off the slope? So where does it say that we're about to leave? Skier loses contact. What does loses contact mean? R equals 0. Perfect. That R is equal to 0. So we're going to get mv squared equals 7 mg cos alpha, because that R there turns to 0. And that's one of our equations. That's our equation using the centripetal acceleration. Okay? So that's all that working there. Now, next thing I'm going to do is I'm going to do what I'm going to do next. I'm going to do the conservation of energy. Okay? So I do the conservation of energy. What we're going to have is potential energy at point 1, P1 plus KE1, kinetic energy at 1, equals potential energy at point 2 plus kinetic energy at point 2. That makes sense? Now, let's go up and have a look. I can rub all that out, because that was all just to do with the centripetal acceleration. Now, how high are we above the ground, or our potential energy equals 0 zone at point A? Point A, guys, any ideas? Finish off this triangle. So, it's 22 degrees is this angle here. So how high are we off the ground, considering that's a 7 and that's a 7? What? I'm going to do it in green. How high is this green line? Exactly. 7 cos 22 degrees, yeah? So, 7 cos 22. So, mgh, mg 7 cos 22, plus kinetic energy, a half, mv squared. What's your velocity at point A? 8. So, a half mv squared, which is a half m times 8 squared. Now, equals potential energy at point 2. Where is point 2? Potential energy at point 2, or point B, is here. So, I'm going to finish off this triangle here. What is this red distance? What is the red height? Here. And that's a 7 again. So it's 7 cos alpha, because that's the adjacent side, and we're using an angle alpha. So it's going to be potential energy is mgh2, which is going to be mg, and what did I say was 7 cos alpha? Okay. Kinetic energy is a half mv squared. Now look at this, guys, okay? See that mv squared there? Any suggestions for a good substitute? Right there, your 7mg cos alpha. So it's going to be 7 over 2 mg cos alpha. The other one is, what's that going to be? 7 mg cos alpha. A half m times 64, so 32m. And then finally this part here. Can anybody tell me what 7 cos 22 is? We'll round it to 3 decimal places. I'm in radians, so I'm going to be wrong. 6.49. 6.49. Now, any suggestions for our next MILF? The M's will cancel. G isn't going to cancel, is it? No. Sorry? Yeah, I think I'll put it in as 9.8. Just work it that way. So, I'm just going to get, what's 7 plus 7 over 2? I think it's going to be 21 over 2. 14 over 2. Yeah, 21 over 2. G cos alpha. And then 6.49 times 9.8. 6.49 multiplied by 9.8, that's 6.49 G. Plus 32. Change it into 95.602. So this here turns into 95.602. We're then going to divide that by 21 over 2G. So this number divided by 21 over 2. And we're going to multiply that 21 over 2 by 9.8. Close bracket. 0.929. Reread the question. Find the value of alpha. So, yeah, I'm on the right track here. Cos inverse that. So, when I cos inverse it, shift cos inverse 0.929, and I find out it's 21.72 degrees. Does it have any stipulation to 1 decimal place or something like that? No, not at all. 21.7 degrees.